All right, so we're going to be looking at how to do missing side lengths when we're dealing with right angle triangles. So there's going to be two. There's one that has Pythagorean and one that we're going to use trig for. That's the trig one down there. So let's do Pythagorean first. Probably remember this from grade 9. Basically, whenever you have a right angle triangle, like we have in these diagrams here, okay, and you have two side lengths, and you're trying to find that last side length, you can use Pythagorean. Pythagorean theorem says a squared plus b squared is equal to c squared. Really important to remember, c is always the hypotenuse, okay? These other two sides are whichever the other two sides are. It doesn't really matter. So we write our formula first, then we're going to take the numbers and sub them in. So let's call this a, b, and c. So a squared is actually going to be 3 squared because I subbed that 3 in. This 4 is going to be 4 squared. And then c squared, I'm just going to write x squared because it was x. Be very careful if you had a question like this, 4 plus y, when you sub it in, it's going to be 4 plus y in brackets squared. A lot of students forget stuff like that. So it was 4 squared. Now we need to actually do the math. 3 squared is 9, 4 squared is 16, x squared is still x squared. So this is going to give me 25 equals x squared. Now we want it to be x all by itself, so we have to get rid of the square. In order to get rid of the square, we're going to do the opposite operation. So the opposite of squaring something is square rooting it. And we're going to square root both sides, and that's going to give us 5 is equal to x. Technically it's plus minus, but because we're dealing with a side length, you can't have negative 5, so it's just 5. Same idea works over here. I'm going to set this question up. A squared plus b squared equals c squared. Remember this one's c because it's the hypotenuse, so we'll do y squared plus 2 squared equals 10 squared. Now the difference you're going to notice is that here we have y on this side, whereas on the other side the variable was by itself already. So I like to square it first, so we get y squared plus 4 equals 100. Now we need y by itself, so I'm going to actually get rid of the plus 4. To get rid of plus 4, we have to subtract 4 from both sides. So we're going to get y squared equals 96, and then square root both sides to isolate, square root of 96. This is technically right. This is the most exact. We could simplify it. We can make it a mixed radical, whatever. If you want to make it a decimal, you can, but you should only do that as your final answer. So that's how you do Pythagorean to find side lengths for right angle triangles when we know 2 of the sides. That was 4. And we want to find the last one. If we do questions like this, actually let's put it this way, okay? We can't do Pythagorean because we don't have enough information. We have one side length, but we don't have the other one. So we're instead going to use trig. So whenever we set up trig ratios, the first thing we do, this is our angle, I'm going to label the sides. This is opposite, this is adjacent, this is hypotenuse. So looking, I have my opposite and my hypotenuse. That means I'm going to do so, sine ratio. Sine of an angle is equal to opposite over hypotenuse. Now I'm just going to sub in the numbers. Remember, this number is the angle. So we're actually going to put 20 in there. Sine 20 equals 3 over x. Now, we want x to be by itself. So technically what you're going to do is multiply both sides by x. So you get x sine 20 equals 3. And then divide both sides by sine 20. Okay, to isolate 3 over sine 20. If you know this and understand that you're basically just taking these two and switching them, that's fine if you want to just write that as your step. So you put this in your calculator and you get the answer. So I'm going to put it in really quick. 3 divided by sine of 20 gives me 8.77. Okay, and then units, whatever centimeters, it doesn't matter. Whatever it was in the question. Now let's do the exact same question. Okay. But let's say we were doing this angle instead, 73x. So if this was our question set up, we would have to use different labels to figure this out. And actually, I'm going to change this. We're going to make that 5. And we're going to make this x this time. Okay. So I'm going to label my triangles just like I normally would. This would be adjacent. This would be hypotenuse. This is opposite. I'm going to set up my ratio. I have adjacent and hypotenuse, so I'm going to use cos. So cosine of an angle is equal to adjacent over hypotenuse. And let's put the numbers in. So cosine of 70 is equal to x over 5. So now all we have to do is multiply by 5 to get rid of this. Be very careful a lot of students will do this and do 70 times 5. And they'll write like cos 350. Okay? Do not do that. That is not what is happening. Okay? It is actually 5 times whatever cos 70 is. Okay? Just be careful you don't make that mistake, because then you get a weird number. So when I actually put that in my calculator, 5 times cos 70, okay, gave me x equals 1.71, which was the hypotenuse. These were different triangles. They weren't the same. They just looked the same. So we got our final answer. We should write centimeters, whatever. That's it. So the main thing to remember, if you're doing sides, you have two sides. Oops. Two sides given. Oh my gosh, highlighter, work. Okay. You have two sides given, and then one side you still have to find. You're going to use Pythagorean, which is the a squared plus b squared equals c squared. Don't forget the square root at the end. If you're going to use trig, that's because you have an angle involved, and you're either going to use SOHCAHTOA or TOA ratio, and then solve for whatever's missing. That's it.